start. Let people join as they come, and start with a recap from last session. And I'm going to share my screen. Azure DevOps. So we covered about what is the purpose of Azure DevOps and what is the problem it is trying to solve between the development and operations team. And right, and this slide we see all the services offered by DevOps, like the boards, repos, pipelines, test plans, and artifacts. And we covered a bit about all these topics. In the last session. And we started with the waterfall model and what was the problem we had with waterfall model and what was the cause for the rise of agile. So people wanted to get things fast to the market. They wanted to deliver quick increments, product increments. They don't want to wait for the complete project to get to the completion stage. So people wanted to get smaller increments or smaller features out to the market as soon as possible due to the competitiveness in the market. So because of that purpose, people started adopting agile as a methodology for the project development. And the rise of agile sorry yes, so the rise of agile prompted or forced team to come up with or adapt some continuous build or integration or continuous delivery method. We have several tools for that, like Jenkins, and DevOps is one of the tools that can address or offer as the continuous integration deployment. And also it offers a source control management. The previously people are using different tools like SPN, Gitbucket, and so on and so forth for the source management. So Azure comes with the source control as well. So you can have your branches, and then you can maintain the version of the changes in DevOps. And these are the problems that we had back then when we were using waterfall model. Releases were infrequent, and we had a confusion between the development team and operations. All these were the reasons why we wanted to go for more modern approach like Azure DevOps. And this is just a summary on what is DevOps. I'll be sharing the document with the team, so you can take some time to go through all the contents. So this is some analogy or a use case of why we would need DevOps. So agenda. So these are the topics we covered, not in detail, but we couldn't get much time last week to cover in detail. But we covered about what is the difference between DevOps, DevSecOps, and NoOps. So basically, DevSecOps is the process of incorporating security as one of the component in your development model. Like right from the scratch, when you start developing your project, security is one main aspect. So whenever you try to push things, the security component will check for the vulnerabilities in your code and raise flags appropriately. And then NoOps is some modern term, like there'll be no involvement of the operations in your development cycle. For example, if you have set things up to automatically deliver things out to the cloud environment or to your infrastructure, then you would not need DevOps, meaning an operations team very often to get your changes out to the cloud or your infrastructure. So that's NoOps. And we covered about the Git basics, and then the DevOps principle. So why people want to adopt DevOps because of these reasons: the culture, automation, lean, measurement, and sharing. Culture is to enable the collaboration between teams, the development and operations team. So they'll be in synergy and will be able to take things seamlessly out to the environments, different environments. So no blame game. Traditionally, we had that issue that the developers would complain about something is working on their machines, whereas the operations team would complain it is not working and the developer had to fix it. So the collaboration communication helps resolve that problem. And automation is the key. We have the build automation and then deployment of automation, which helps the team to deliver things faster to the market. And lean, which is we don't wait for the complete product to get completed. Instead, we deliver incremental values. So that's a lean. Measurement, it offers us ways to measure metrics of how your application is performing. Like what is the response time, like what are the other issues that you have with your application, and so on and so forth. and sharing. So with different teams coming together, we get to know the infrastructure, because most of the teams would not aware of what are the underlying infrastructure that the operations team use to deploy the changes. For example, one team would work just on the development. They would just keep pushing the changes to the server, but they would not know where the code gets deployed to or the underlying infrastructure. And DevOps helps team to get some visibility on the infrastructure, or the operations team that manages the infrastructure. So that's sharing. So these are the features that we covered in detail, and the phases of the development side and what does the operations do is what depicted here. And this is the life cycle of DevOps. So what happens is that the developer pushes code to the Git repository, and then the pipeline gets triggered, and it gets all these stages passed. And after that, it goes to the release pipeline, and it deploys to the different stage environment. And so this is the difference between DevOps and NoOps, and the comparison table. So SaaS, PaaS, we have covered that in detail last week. So for this week, for today, we are going to cover the branches and repositories, and how can you work with multiple branches or feature branches, release branches, hotfix branches, and how can we make code changes and commit those to the server. And so after that, Praiseson will be taking over the branching strategies. So we have got custom branching strategy implemented with Simpay. So Praiseson helped to implement that strategy for Simpay. So he'll be explaining what were the challenges that we had faced with our team, and how the branching strategy that he implemented overcome those challenges, and some introduction to pipelines and YAML files, and then CI/CD. So we'll see whether it would be able to get to the CI/CD in practical. If time permits, we'll be covering that, or we will cover that in the next session. And then work item types, and then backlog and sprint planning are the features. So before we jump on to the code side, this is probably most of you must have have this sheet, Git sheet. Those who are very comfortable with using commands would really love this sheet. So people tend to use Visual Studio for managing the source control, or taking changes to the server. So with that, let's go ahead and quickly build a project, or create a project in Azure DevOps. So for that, you would need to navigate to portal.azure.com. So once you have navigated, you will see all the resources that you have in here, and you could shape for DevOps, and you will see Azure DevOps organization, and you could go to my Azure DevOps organization, where it would list you all the organizations that you have for your account. And for me, this is the default org. I'm going to create a new project. All right, I'm going to name this, let's say, the first awesome project. And you have options here. So if you want to make this project available for the public, you can choose public, or you can choose private. So if you choose private, people, only within your organization, or people who you enable access to, will only have access to this project and would be able to push code changes to it. So with that, we'll go ahead and hit create. All right, so our first project is created, and obviously we don't have anything in here. So we'll go to repository. Repository is a place where we would manage all our branches and commits. So what I'm going to do is I'm going to go to branches, and it offers us ways to clone, repository. So what I'm going to do is I'm going to create a project and push that project into this, DevOps project. So for that, what I'm going to do, I'm going to launch a command prompt. I also opened the Git sheet in a separate window. Right, here we go. Okay. Great. So I'll go to samples and let me create a new folder. Uh, the, let's go with our traditional naming, Hello World app. So you will need to go into that app. So .NET, so I'm going to pick .NET for the sample. So I'm going to create a console application. For that, you will need to provide .NET new console. So this would create a console application within that folder. So we have the project created. So now the first step is to initialize a repository. So we would need to use a Git init. As you could see in this cheat sheet behind, the first step to set up is to use the Git init. So we have other preliminary steps here, Git config, which is to set your username and email. So we'll go with Git init, and that initializes a repository for you. A repository is nothing but a place where you can keep all your code changes or branches. So that's the repository, and we have initialized our repository. So the next step is to add those files. So after we have created the project, it has created all these files, right? So we want to add all these files to our repository. So for that, you would need to use a git add, and you could use file name or you could use period to add all the files. So if I use period, it would just add all the files from the current directory to the to the repository. You could use git status to see the current status of the git. So all these files have been added newly to the repository. So next to that, so let me try to use push. And what it says is that no configured push destination, meaning the repository doesn't know where to send all these changes to. So for that, we would need a URL where we can push all these changes. So for that, we can go to DevOps and grab this, line of statements. So git remote add origin. I have copied it. So let me just paste it in a notepad. Maybe not a good idea. So you would see the first command is git remote origin, and then is the path to the project. I'll copy that and paste it in here. So now that the remote has been added, the next step is to push the changes. Git push. Now we see that it doesn't know what should be the default branch name. So for that, we need to specify the upstream name. So we set master as a name for our branch.
You need to commit, I think.
I'm sorry?
You need to commit.
Yes. Thanks, Karthik. So we'll commit the changes. This is the initial commit. All right. So now the changes have been committed and ready on the master folder. So the changes are being pushed to the server now. All right, so the changes are pushed. Now, if we go ahead and refresh, you would see the default branch, which is the master branch. So the master branch is usually the main branch that people use for tagging the changes. So you can consider that as a working branch for your application. So people generally try to create future branches off of master branch. So we have a couple of branching strategies. Probably Praiseson would cover that in detail. So what I'm going to do is I'm just going to use the rest of the commands here. So we use git init and then add. So git difference are all the commands that you can use to compare the differences between your working directory and then the other branch. And then so git branch and branch name. So git branch are used to create a future branch. So for example, if you want to know which branch are you in, you can use git branch, and that will tell you which branch are you in. And if you want to create a new branch off of this branch, you can use git branch space feature one, and that will create a new branch called feature one. So we have the new branch created, but still the current directory is master. So to switch to the feature branch, you need to use git checkout and the name of the branch. So now it is switched to feature branch. So you would see the feature branch is now selected, which means that the branch is now switched to feature. I'm going to make a simple change to the feature branch and show you how we can take that to the master. So I'm going to pick a program.cs and make a change. Save it. So now if you see, we see that we have one file has been modified, and we can use commit to commit the changes.
You need to add.
Okay, so we would need to save the changes. So what are the file we have changed? So if we use git add dot, whatever the changes we have made, all the changes will be committed. So once the changes have been committed, we can then use a git commit. So then now the commit is successful. Now the next statement is to use a git merge to get your changes to the master branch. So let me just go ahead and push the feature branch. Okay. Now that we have two branches pushed to the server, so we have a change made to the feature one branch, and we are going to merge that change to master. So we can use a git merge command for that. So before that, we would need to switch to the master branch. So what I'm going to do is I'm going to switch to master. Okay.
You need to switch.
So now I'm going to use git merge and then the branch name, which you want to merge to this branch. So we have one change that is merged with the master branch. So if we see now, we have nothing to commit, so we would need to use git and dot.
And just git push.
Sorry, Karthik.
No, the merge command will merge the commit of feature into master already.
Correct.
So you just have to push.
But git status would show the changes that have been merged, right?
Yeah, it's already showing like your branch is ahead of one by one commit.
Right. So now that the changes have been pushed, so now if you go to master branch, we should see the change, the first thing. So so that's how we create a feature branch and merge the change to the main branch. So we have a lot of further commands that we can use to track the git changes to the git commands. But in our team we mostly use Visual Studio for all these operations. We don't work with git commands. So, but for people who doesn't have Visual Studio or has VS Code but are good at using commands, so we can make use of this cheat sheet for Git related operations. So yeah, that's the branches, and we'll switch to the presentation. So branches, and probably we'll start with branching strategies. what are the different branching strategies and how we can pick one for our development projects. So this now is mostly for the developers to manage their branches. So yeah, so with that, I'll hand over things to Praiseson to cover the rest of the topics. All right, Praiseson, all yours.
Thanks, Deepan. So, can you able to hear me?
Yes, Praiseson.
Yeah. Okay. As you see the first screen, so this is about the grid branching strategy. So the first screen you're able to see is that the grid branching strategy. So it is commonly used among small teams. So where they have only single branch, like main branch. So where they get the features from the main branch and they work on different features and they create a PR to a main branch. So this is a simple, branching strategy which is very useful for small teams like 1 or 2 members. And we have some, while creating a future branch from the main branch, so we have some common naming conventions like different developers, different teams use different conventions like they use their username with the description of that item, what they're working, as well as if they are working any bug fix means they would mention that bug name and the description of that bug in that future branch name, and they will create those branches from those. So this is a simple branching strategy. So I'm going to go with next is the Git flow future branch. This is a main branching strategy, so which is commonly able to see. In this, you can able to see like there is only 2 branches, like main branch and develop branch. So main branch is a branch where if we push any changes to the main branch means it automatically deploy to production. So that is main branch, and develop branch is where where the developers used to push the changes and that will deploy to the test or UAT like those environments. So first in this approach, the developers used to get the changes from the develop environment, like they create a separate feature from the develop branch and they try to work on what are the work items, are there any bug item they are working. So they used to work, and after the confirmation they will create a PR from their future branch, like their future branch to the develop branch, and after that these changes will be deployed to test environment. So this branching strategies they used to in Azure YAML files, they used to manage like each branches can be monitors, like some validations we can able to place in the Azure YAML pipeline. So based on that, they will be deployed to the various environment like test, UAT, and productions like that. So currently here they create a future branch, and once they are done the changes, they create a PR to develop branch. In this approach, after they create the develop branch, so these changes will be moved to a test and UAT environment. So the in UAT environment where the QA will test those changes, and once everything is working, the QA will create a PR. So that is like a.
So let's pause for a moment, Faizan.
Yeah.
So where are the branching strategies? So of course, we had some issues in our, in our team with
Yeah.
TeamPay with using the branching strategy.
Okay.
So let's also hear from the teams on what branching strategies are they following, and what are all the challenges that they have currently that we can help to resolve. So, team, can someone share some insights on what branching strategies are you using for your development? Anyone can volunteer and share your, branching strategy.
Hi Deepan, Manoj here.
Hi, Manoj.
Yeah, for OSV team, we use a story-wise branching strategy. So each user story will have the one branch, one feature branch. From that, we take a task branch and create a task, and then merged that to into feature branch. When all the feature is development is completed, then we directly merge into master branch. So every day the master branch deployed to masters, the production environment. So
Okay.
the branching strategy in the OSV.
Great. So you're adopting the Microsoft's, default branching strategy. So what we see here is the default strategy offered by, Microsoft, which is, pretty simple and straightforward. Um, So, for example, just like how Manoj just mentioned, you would have the main branch or master branch from which you would create a feature branches. Features are nothing but probably you might be working on a specific user story or a task or epic. So for that, you would create a separate feature branch, and once the change is done, you would merge those changes into the main branch. So the main branch will get the changes onto your target machines, like it could be the production server, or it could be the VM, production VM, or it could be app service or anything. But the main branch is the master branch that will get your changes out of the production environment. So Manoj, I have a question. So do you face any challenges or any issues working with the current strategy?
Actually, here in OSV we have around 40 people working. So we need 40. So at that time, 40 user story will be happening. So each story will have. So in OSV they have 48 environments. So we need to update all the environments, and so maybe the cost of the development environment is higher. So we have because we have 45 environments. So but we can independently work and then QA also. So in OSV the everything is automation. So one feature is completed, they write a automation and test it against that environment directly. So
No,
maybe cost is higher. That is the only concern, I guess.
got you. So so what I understand is that OSP team would develop, features on their own, and they don't depend on other members' feature. So whenever their feature is completed, they would just deploy that change to that environment, specific to that developer. And once that change is tested, they would push things over to the production. So that's how OSP team currently works. And I think, as you mentioned, the cost is higher if we want to take just that change to the server, then I don't think you would have another option but to have a separate environment spinned up for you. But if you can get your changes piled up or planned for the sprint release, I think you'll be able to reduce the cost to the significant amount. But it's up to the organization's decision and policy on how they want to get things structured. Um, but the problem with that, branch, which is the Microsoft adopted branching strategy, is that you have feature branches created out of the main branch. So that way, you don't really have control over what changes. For example, let's say that there are multiple developers working on multiple features out of the master branch, and you have a 2 week, let's say 2 week sprint, and you want to stage all those changes onto a test server. So with this model, you don't really have a way to test, things by your testing team. For example, let's say you have a separate testing team and you have an UAT environment or testing environment where the QA develop QA, persons can play with. In this approach, you will not be able to get things out to UAT because once you complete the feature changes, you directly merge that into the main branch, which will take things to the production. So if you have automated test cases within this branch, the pipeline will fail. So the developer will fix the change within the feature branch and will then push a change to production. So you don't really give a chance for the testing team to do the rigorous testing in case the manual testers if you have in place. So the one in here at the bottom, this is what we had followed previously. So whenever we do the sprint release, we would just create a separate release branch off of main branch, and we would start working on that branch. And at the end of the sprint, we push things to the release branch, and release branch will push things to staging. And once testing is complete, we would then push that to main branch, and that will get changes deployed to production. So we have some challenges, with this approach. So I think the next following slides, we would cover what challenges we had and how we address those challenges. And other thing that Manoj has mentioned that he, shared about how the team manages or organizes the branches, feature branches and bug fix branches. And these are some of the ways how you can manage those branches. So you could just have users as a folder, and then you could have names or initials. Under that, you can have the work item or the description of the item, or in some cases, we follow work item number to track or organize the structure. And if it is, we can also organize it by feature or bug fixes, so that you group all your bug fixes into a bug fixed folder, or all your features into a feature folder. So at any point of time, you'll be able to say, what are the list of bug fixes are being worked on, or the list of features being developed. So hotfix is something that we can do at any time. So it doesn't have to necessarily follow the sprint release or wait for the sprint release. So it can happen anytime over the sprint, or how many times, many number of times over the sprint. So that's just the Microsoft default model. And thanks, Manoj, for sharing that information. And yes, Praiseson. So you could start with what challenges we had in Simpay, and
Okay.
how we resolved those challenges with the use of or with the adoption of these strategies.
Okay.
Yeah, Deepan, only one thing to add. So you said the problem to the statement, right? So if it is UAT can't test it thoroughly, right?
Yeah.
So in OSV, what they follow, they use extensively the uh, f- um, um, feature flags. So everything developed under feature flag. So uh, they don't turn on immediately after went to production. So they use um, most of the feature, it's behind the feature flags. So every time they develop again back feature bag, so the UAT team can test those, and then if they good with that, then only they turn on the feature flag. So
Right. Yep.
yeah.
So feature flags is same one option. So to test and we can validate the changes, and once the changes have been verified, we can switch the changes. But that's a good concept. But we don't have an extensive environment. For example, if you have UAT, UAT is the acronym of that is user acceptance testing. In some cases, not just the testing team, but also we would want to roll things, or share things with the end users to see, to gather the feedback, or just to give them a glimpse of what features are planned to roll out. So in which case, if you have a separate environment that the users can play with or test around, then I think would
We
add.
do have a CA environment, right?
I'm sorry.
Manoj?
CA for the developer, maybe we have a demo environment also.
Yeah, demo.
Yeah. So yeah.
Okay.
Uh,
Deepan, I want to add something
Sure.
to this. There is basically in EC Labs, we follow your OSV and other teams were working in a single product or multiple product with multiple developers. In EC Labs, as a project manager, we handle a lot of products. So in order to, I think you mentioned the branch names and all techniques. We followed the branching techniques called as, we named as a leader branches, so that any feature, any developer can create it, develop. So those can park into the leader branches. Once they finish it up, we move to some other environment in order to give it to the testing. So we have separate environment for the testing thing. And then once the testing is done and the bugs are resolved in that thing, we can move it to the develop branch and then main branch. So this way we successfully, I'm able to, there is as a production release manager, I'm able to release multiple products in a week time or in a month time. So this will give a lot of opportunity to do a testing of lot of items in different environments without any crashing of other development stories and all. So this I want to add something here to the thing.
Yep. So that's good thing to share. Thanks, Nancy.
Yeah.
So if you have things isolated, then that will give people a lot of flexibility in testing and carrying out changes and
Yeah.
moving things around. So
Yeah.
thing is that different teams adopt different naming conventions. End of the day, the concept is just the same, having a
Yeah.
separate environment for the separate purposes. But still, I think one of the slides in here that depicts exactly
Mhm.
what Nancy has mentioned, but in
Yep.
different terminology. So probably Praiseson is going to
Yeah,
come.
yeah, it's correct.
Yeah.
So thanks, team, so for this input. And so currently, this is a Git flow, which we previously, checked as a reference, and it has, a main branch as well as develop. In this, previously we used to work like this, and we faced issues like, consider, the latest changes the developers used to get is from the develop branch, right? So once the developers get the changes, consider myself, Mugilan and Deepan are working, get the changes from the develop branch, and they started working on different work items. And once I fix my changes, work items, I create a PR to develop branch, and those changes have been merged to develop, and that will be there. At the time, Mugilan, get the changes from the develop, and he started to working on his item. In some cases, I may, push some bugs, issues in my issues from my feature branch into the develop branch. So that might be merged with the develop, and Mugilan might not know whether those changes are there or not. He might know that the develop branch is the latest branch, and he will take those changes, and he started to work on those changes. Uh, After that, consider Mugilan changes to be, a major bug, major release item means, in that case, have pushed a bug item for him. For that, so Mugilan has to wait for me, since it has some bug, issues involved in in the develop branch, right? So he have to wait for me to fix those changes and create a PR. Then only he need to get the latest from the develop and merge with its feature branch, and able to push those changes. So we have some. I mean, like if there are 2 or 3 members means, it is okay, but consider if there is on-site members also. So those changes is difficult to handle, and we ran into many errors like this. So, and mainly we ran into, this errors like, if developers are working on a same file means, they may run into merge conflicts, and while resolving that merge conflicts only, we used to get those developer changes. Other than that, everything is fine. But in some merge conflict cases, we used to get uh, I mean, those changes. So what we try to do is that a custom branching strategy, so which we have checked in multiple websites, and multiple companies have do their own, as Nancy said. So they are using their own branching strategy. So the terminology is only different than for same. So currently, what we are following is that we have like a 4 branches like master, integration, staging, and develop. So these are the 4 branches which we have created. So uh, this the develop branch is that whenever we create a PR to develop branch means it will deploy the changes to test environment. So test environment is only for the developers to test those changes. So instead of, in local we used to test our changes, right? So in server there might be we might run into errors like so. To test our changes in the server sites, we used to create an environment for developers. So that is the test environment. So where developer will push the changes, and they will test those, and staging is for QA. So whenever we create a PR to staging means, those changes will be deployed to the UAT environment, where the QA or they used to test those changes. Once everything is done, they will create a PR from staging to integration. So first, what main branches? So we used to get the latest from the integration branch only, so not from staging or anything master. And also we used to get the latest changes from staging from the integration branch. So this considered as a master branch. So where we used to get the create a PR, feature branch from the integration branch, and we used to work from different changes, as well as Mugilan also can able to get the latest changes from the integration branch. So you also work on separate item. After that, if I fix my changes means, I will create a PR to develop branch. So in this develop branch, those changes will be deployed to, as mentioned, like test environment. So I will test my changes in the the test environment, and if everything is work fine means, then from my future branch I will create a PR to staging branch. So in this the develop branch itself, so we have some gated checking. So for develop branch we don't have like a gated checkings, like whenever we create a PR means uh, some main authorities used to check our review our codes, right? So whether our code is in the correct format or any things need to be verified. So we have some gated check-in. So for develop branch, we don't have any gated check-in. So for staging and integration, so we have some gated check-ins, like some authorities like Deepan or they're like some other members, testers used to have some authorities. So whenever I create a PR from my feature branch to staging branch, so those PR will be there for their approval. So once they see my PR, they can able to see the list of files, and they can approve whether my file is after that it will automatically deploy to UAT environment. So after that they will the QA will test those changes, and once it is success means they will create a PR at last to integration, from staging to integration branch. So this is how we have successfully worked on multiple projects, like. And here we don't run into multiple developers. Even if they push any bug items or any issues in their code means, we are able to identify in the develop stage itself. In the develop environment itself, we used to identify my code is not working or any changes is not working itself. I will identify at the test stage itself, not at the QA or at the production stage. So we have identified in that stage itself, and we used to fix those bugs, and we will create a PR to staging. In staging, they once again test, QA will once again test our changes, whether it is working as expected, or if they come under the criteria. Once all is done means, they will create a PR from staging to integration. So this is from integration, it automatically deployed to production. So you may ask, like, why there is a master branch. So after the production deployment, from integration to the production environment, so we wait for 2 to 3 days just to check whether the production environment is working as expected or run into any issues means. So we will create a PR from mass integration to master branch as a backup file. So it's a main backup file. So whenever the integration branch is any crashed, or some cases mean, we used to backup from master branch to integration branch. So we don't use any master branch to deploy to production. So instead we use integration branch to merge, push the changes to the production branch. So in this approach, the integration branch, we don't run into any multiple developers any issues, or any untested changes. We don't run into any issues, like, since this integration branch is fully tested, as well as it is running in the production. So even if myself or Mugilan or Deepan, if they take any feature branch from the integration, so it will be clean. So no untested changes or any issues will not be available in the integration branch. So that's how this custom branching strategy works. So any questions, team?
Thanks, Praiseson. So that's a pretty detailed, thoughts. But I'll share some more thoughts, which is he got about the integration branch, staging, and develop branch. So the dev deploy in here is called the develop branch, and these three branches are associated with environments. So, like, for example, the develop branch is associated with the test environment, where we have a server for exclusively for the developers to play around. Like, they could introduce some new concepts or technologies, and they can see how that works in the server. So ideally, all these three branches or the environments will be consistent. So the operating system or any other software running in the develop branch, mostly the staging and integration would be same, but the develop branch, it might have some additional softwares. So we need to maintain consistency in all these three branches, and staging have a separate environment for the BA team or the testing team to test their changes. And integration branch is what we consider the production branch, meaning any changes merged into integration will trigger the pipeline, and we'll deploy the changes to the production. And once the production is stable, we monitor the release for 1 or 2 days. And if it is stable, we don't have any errors reported, when we tag those into the master branch. So master branch is nothing but a tag to tag your changes or the code. So he explained about the problem that we are trying to solve with these branches. We actually introduced an additional branch called integration and staging to avoid stepping onto each other's changes. So this is how we currently use our branching strategy, and this turns out to work really well. So we don't have any issues with this approach. So this is how it currently works. And so we'll switch to Azure DevOps to get into some action.
Deepan, here one more question for me. So we have so do developer worked on two different user story, both in the testing environment, but for some other reason or requirement reason, uh, one user story never went to integration branch. Okay, but uh, it is in staging environment for entire time, maybe after a month also. So but in PR and all, if we merging dev changes to staging, giving PR to dev to staging, um, still some never went to integration branch is there. How do we solve that problem?
Right. So the first clarification that I'd like to bring is that we don't usually merge develop into staging. So we merge the feature branch into the develop branch at first, and when the change is deployed to test, they test the changes thoroughly if everything is working as expected. And if it works, then the developer will create a PR from feature one to staging. So that's what you see in here. So the first PR is to feature one to develop branch, and then after confirmation they would create a PR from feature one to staging. So the developers would not create a PR from develop to staging, Manoj. So that way the user or developer has the chance to check or validate the change before moving that into staging. So we have
From staging to integration, then.
yes. So for example, let's say that you have 2 weeks sprint release plan,
Mm-hmm.
and you have multiple developers working on it. And for some reason you want a particular change, you want some more time to test that change and not want that change into merge into integration. So for that to happen, what you can do is you can just cherry pick and get all the changes before that commit and push that into integration. So that way you'll be able to ignore the last commit or the commit that that you want to ignore, and get all the other items cherry picked into a separate branch, and you can take that branch into integration. So if things are pressing and you want to take that change to production at any cost without this change, probably you can choose this approach. Or if you have time for testing, then you can choose to have some additional time, and once the item is verified in staging, you can then push changes to integration. But cherry pick is the way to pick your changes, and meaning selected changes, and move them into integration branch. Does it help?
Uh, yeah, sort of, because in my previous company, the staging server, so we um, uh, maybe in small teams it can happen. Mainly the staging and the integration go out of control. There are a lot of difference in staging server, so a lot of feature in the staging server, but that never went to integration. So there will be a lot of differences between these two branches. It's hard to maintain the staging branch um, easily, so there will be lot of conflict in the feature to staging. So
So
uh,
one other item or point I'd like to add is that not all the branching strategy solves all the problems, because there are some things, some nuances, like we need to have some process and collaboration in place with which we'll be able to sort out some of the problems like this. So if you want to have, we would need to have a clear process of the sprint planning, so that way you would know what are the items that we are planning for the sprint. And once the developer has completed the change and you want to move that change to staging, and for some reason, if the change is not working in the staging as expected, the testing team would request the developer to fix it. And after multiple, attempts, let's say you don't want to move that change to production, I think you'll be able to, revert to the previous version before that commit, and take things to integration. Probably what we can do in the next session, we can try to simulate your scenario and see how we can, come to a resolve for that problem, if that works for you.
Yeah, thanks, Deepan. Yeah, thank you.
Great. So we have 5 minutes left. I'll just quickly walk you through the various pieces that we have in DevOps. So we have the pipeline section. So we'll go next session, and we'll cover about the pull request and merge conflicts, all those stuff. And in here we will just quickly touch based on some of the items here. So we have pipelines. When you talk about pipelines are the way we can implement CA and CD. So continuous integration and deployment. So we have for pipelines to work, we would need one important thing called agents. So agents are nothing but your build agents, the servers that can build your application. For example, let's say you have a repository in here in Azure DevOps, and for Visual Studio you have MS Build that can build your project and gives you the EXEs or DLLs, right? But in DevOps you all have the repository, but how does the system build your code changes? So for that to happen, you would need to have pipelines in place. Pipelines are classified into multiple types, like self-hosted agents, and then Microsoft hosted agent, and third version is agentless. So self-hosted agent is that, let's say you're dealing with a sensitive information or confidential information, and you have some dependencies with the operating system, and you don't want to have a Microsoft agent for building your code dependencies. So for that purpose, you can go with self-hosted agent, meaning you can have your own build servers. It could be a virtual machine or your machine at your own premises. So you can have that machine as a build agent. So once the code is pushed to the repository, it will trigger the build agent. So the build agent that you have on your on premises or the VM, it will grab the code from the Azure DevOps, do the build, and produces the artifacts. So that's the responsibility of the build agent. So once the build is successful, it will then pass on the things control to the next stage, which is the delivery or deployment. So for pipelines, we have two options. One is to use the classic editor, and then the other one is to use YAML pipeline. So the classic editor, using which you'll be able to configure things in the UI, like what stage you want to add or edit. So everything can be configurable using the UI. On the other side, with YAML, so YAML is the acronym of that is yet another markup language, with which you'll be able to create a code or structure that can help you get your infrastructure delivered. So that's the YAML file. So with we are short of time, so we'll cover in detail about the YAML in the next session. With the classic editor, it offers a way to grab the source code from variety of repositories. You could pull your changes from GitHub or any other repositories like. So you need to select the project that you want to set the build and the repository, and then on which branch you want to select the build. So once we select that, so it is asking for which programming language that you want to create the pipeline for, and I'm going to select the ASP.NET. So this offers the predefined set of tasks. So these are the tasks that would run in sequence. It will try to grab all the dependencies for the package and then restore it. It will build the solution. If you have any test cases, it will run the test plans or test cases, And finally, publish artifacts. Publish artifacts is nothing but the artifacts are the outcome of your project. Like it could be, DLLs, EXEs. So those are called artifacts. So these are the predefined steps. And if you want to add any custom steps, for example, if you want to grab some data from, a API or any other endpoint, you can add a custom step. So you can add a task here, and you can choose what task you want to add to the pipeline. So Microsoft offers a variety of tasks. All these things can be done programmatically using YAML files, so which we'll be covering in the next session. So I talked about pipeline and then the agent. Then how does this deploy the changes to the target server? Let's say that we have a VM running or on-premises server running. So how would DevOps know where to get the changes? So for that to happen, you need two important things. One is the service connection, and then the other one is environments. So environments manages different environments. For example, it will be test, production, or UAT. So you would just name your environment in here. You will create all the environment, test, UAT, and production. And then for the DevOps to reach out to the target servers, you would need service connections. So service connections are something called the agents that can help facilitate DevOps to take your changes to the target platform. It could be AWS, it could be Azure, or it could be your on-premises. You can name it. So these are the variety of options that we can use. So for if you want to work with Azure resources, you can choose Azure Resource Manager. So and then you would select the subscription that to which you want to publish your changes. It could be containers, Kubernetes, it could be virtual machines, or it could be app services. So whichever the resource that you want to deploy to, you'd be creating a service connection here. So service connection here, we can think of it as an identity. So DevOps presents itself as an identity. Hey, I have this permission to access your resource and complete the deployment. So the Azure knows that the request comes from the legitimate source and allows the deployment to complete. So this is the way DevOps communicate to other platforms like Azure or AWS or on-premises to complete the deployment. So we'll cover this in detail probably in the upcoming sessions. So I think with that, we'll close this session and we are open for questions. All right, so looks like we would have more questions when we see things, in practical. All right, so I think that's all we have for today. Thank you so much, team, and you all have a great day.